Hello everyone. In this video, we are gonna look at how to divide a monolith into microservices and in how many microservices. Like what is the number of microservices we should divide a monolith into. It is a tricky situation because there is no such number or a way to get number of microservices for a monolith. It depends on the use case. So let's look at few of the expectations, few of the high level and important points that a microservice should always have. Now, number one, they should be loosely coupled. A microservice should be loosely coupled, means updating one should not require to update another one. Means if there are two microservices, if you want to update this one, then it should not have any impact on the next microservice, which means they are loosely coupled. Second is engineers should be able to code independently, test independently, and also deploy independently these microservices. If there are four microservices, so there should not be such dependency that causes engineers to collaborate together in order to run on any specific microservice. They should be able to work on all these four separately with their own release cycle, test cycle, and management cycle. Now, second important point that arrives is the third one, I mean, less communication overhead, which means that for each small operation or information you have to communicate with other microservices. So this should not happen. More or frequent communication between two microservices means you should merge them. Like they are not meant to be microservices at the first place. Because if there are two microservices and they constantly need each other's support to perform properly or to work, then they should be a one microservices. They should be a one microservice, not two. So that is why we are saying that we have to keep them loosely coupled. So if they are talking too much with each other, which means they are not loosely coupled. Now I think this is already covered the point which is scaled independently. Like they should be able to scale independently. As we saw in the previous video, the benefit of having microservice architecture is if any specific microservice is getting too much traffic, so we can just scale it up. There is no problem in that. So they should be able to scale independently. And the reason we just discussed is if they are talking with each other, there is a lot of communication overhead among two microservices. There is a certain problem and they won't be able to scale independently. So we have to reduce, and we should not have it at the first place. Now this was the first question, like how to divide into microservices. Now the second question, which is what should be the number, like how many. So this is where we get a little confused that what should the number should be. If an interview someone asks you that I have a monolith and I want to divide it into a microservice, so can you give me a number that how much, how many microservices it would be divided? So in our last video, we talk about a domain-driven development, basically where we tend to divide a monolith into multiple domains, a domain-wise microservice. Then we again divide them into monolith, and then first we divide it into, let's say, sub domain, right? So there are multiple domains, and then these can be divided further into subdomains. It all depends on the size of the monolith and operations you are doing. So for example, if there is a payment, and in payments there are multiple activities like refund, forward, tracking. Application is big, that may cause a need to have a separate microservices for a particular operation, and it may not as well, depending on the requirement. We can say that to follow domain-driven design approach, that might help to get a number based on the domain. But with this, still we won't be able to get a fixed number because it depends on engineer to engineer and use case, and there are multiple angles to look at it. For example, some may look at technology level, some may look at database level. For example, they will say that let's divide it into read microservice and write microservice. They may look at, like, of course, some other way. The DDD is found suitable for interview question solution approach. So we will always say in an interview that okay, let's I will use a domain-driven development to try to figure out the number of microservices that we need. Now there are certain steps to help you whenever we are doing assessment in an interview and we have to answer this question. So there are some phases that we need to follow, or we can explain those phases to the interviewer about converting this monolith into the microservice. So first is you need to understand your domain, because without understanding domain you won't be able to divide it on the domain level. Okay, and how we can do that? You have to basically sit with the domain expert, because they know the domain requirements and domain knowledge, they have the most. So we have to discuss the problem we want to solve. We have to sit with the domain expert and the users as well to do a perfect concrete division among them. Now once this phase is done, So this was the phase one. Once this phase is done, we move to another phase, which is coming up with domains, subdomains. Now let's move to phase two, which is coming up with subdomain. This is phase two. Now there are a lot of questions that how to come up with subdomain, because each subdomain has the capability to become a microservice. So that is why we have to be careful and concrete about domains that we are planning to come up with. An example here we are taking of a simple application. Let's say we are taking a simple application, chat application, or you can take e-commerce as well. Now for this chat application, we have to come up with, let's say, domain. What are domains? What are possible domains? No concrete, but what are the possible domains? Can be anything, and we have to come up after we sit with the domain expert. Now I know about an approach which is followed during DDD, which is event storming. This is the approach which is followed to come up with the domains basically. So you do the event storming and it helps to determine the subdomain. So they are connected. Now what happened in this is, in this we all sit together, domain experts, developers, decision makers, stakeholders, and do a whiteboarding session. Now how does whiteboarding session look? So a whiteboarding session is done, and this is what is the event storming basically. Everyone here will come up with possible operations that is possible, and how does it work is simply take a look. First is take out all events, then second is sequence it and find missing event. After that, bounded context is decided for a group of sequence of events that is that we came up with and we found the missing one. Then the boundary context is being decided, that which group of sequence relies in which boundary. We will look all this in detail just a moment and repeat it. Once this whiteboarding session is done and bounded context is set, the final microservices are basically derived, and they are derived from this bounded context in general, but this is outside of the whiteboarding session. Now this happens in the same session, but this, once a boundary is set, a bounded context is set, then it's become little bit faster to come up with the microservice. Basically, we know the flow of any events that is happening, and then we have bounded those events into a specific boundary that these events will happen only within this. It cannot go out. So that has the capability to become a microservice. Now, let's look at these whiteboarding activities we done in detail. Number first is take out all events, and what we are doing, we are taking our chat application we are taking over here. Now how does this happen? Now in this session, in the first activity, all the participants sitting in the whiteboarding session come out with events. They think all the events uniquely, individually, and they wrote it down in their own notepad. No one knows what someone is writing. And event can somewhat look like a list over here. Let's look at. So it can be, first event can be user registered, then user login, then message delivered, message has been read, message deleted, or let's say message edited as well we can add. Now these all are events, right? There is a possibility that some might be missed or some might not be applicable as well. So it depends. So first we come up with all the events possible, and then all the events that have whatever is coming in your mind will be there on the blank canvas of each and every one, and then they will be collected into one. There is a possibility that we might have missed some event, or there might be some events that is not applicable, or that is, let's say, out of the scope and may come in next version. So it is possible. So the first logic is to come up with the event, and then we look at the missing one. Now once this is done, second phase starts, which is sequence it and try to find missing one. Everything is happening in the same whiteboarding session. These are not different sessions. They are the same sessions but different phases. Now we saw that in this we have these events that was decided. So what is the sequence here? User registered, then user will log in, then message sent will be there out of these events we have, then that message will be delivered, then message may be edited if someone made some mistake, so it can edit, or message delete. So these are all sequence that is possible, right? Now in this event we notice that there is one missing event. That once user log in, there is a possibility of user log out as well. So this is one missing event, and here the sequence might not be in the same direction. Let's say there is a possibility of some different direction as well, or multiple directions. For example, when the message was sent and message was deleted, so there was a possibility like before sending someone might have deleted it, like before the message could be delivered someone deleted that message. So that is another possibility. Then message read can also be one event which is let's say because user can perform multiple operations parallelly. For example, user might have sent the message first and then users decide to log out, or let's say user just type the message, sent it, and before it could be delivered, user logged out. Since it's running on a server, user doesn't care whether it is delivered or not, so it will just see that it is sent. So this is one possibility. So if we want to reiterate this all, so there is a possibility, let's say, let's write it again. So now we move it a little. So from here, as we discussed above, user login, user may log out, or user may do second one, message sent. Now here we may have a same object, obj1 and one also. Now let's look at here. The context of object 1 might be different than the context of the same object in the boundary second. Means you see the object 1, it may perform or behave or valued little differently in this particular boundary 1 and differently in this boundary number 2. For example, if you see, let's say the context of this boundary is it's a restaurant and this is a dustbin. Now in a restaurant you will have a sandwich and the value of this sandwich in the restaurant is much more than in a dustbin. Getting my point? So here for the context of restaurant, this sandwich is valuable and you will pay for it. But on the context of dustbin, if the sandwich is in dustbin, means you will not pay for it. It's a garbage. So that's what boundary means. It's specifically like a polymorphism in Java, but in a different way. An object behave differently in different environment. So that's what it says in general. Now, a very important point after that, understanding boundaries, like these should not be interdependent. So there should not be any dependency among these two boundaries. There should not be any. So they should be completely independent. It should be independent of one another. This is a very specific property of bounded context. Now let's say now we have to identify the bounded context. So once we have a sequence, we have to group them in a logical related event. For example, group of logical related events is equals to one bounded context. Above we were talking about a lot of user sequence where user is getting registered, user is getting logged in, user is getting notified. But let's see what works, what not. So now when we say user registered, user login, user logout, so let's say just remove user and we just put the main activity that we are doing, main event we are doing, which is register is one event, login is one event, logout is one event. Now the common is user is common among all those. User is registering, user is logging out, and user is logging in. So we can call it as a user management bounded context because here all the user related activities are happening. So we can bound it, we can call it as user management bounded context. Here what something is happening on the user object, like, and if we dig a little deeper, then we can say something authorization, authentication, these activities are happening, right? So these are what we have: authorization, authentication, and then permissions will be granted based on the user role as well. So we are doing a lot of user related activities, we are managing user related activities here, so it will be called as a user management bounded context. Now next bounded context that will be performed is created with is we are doing a lot of message related activities as well. So what now you may understand already. So what did we events was delivered, deleted, edited, right? So these are the major events that were happening there, and this we were performing on a message object. So what we can simply call it message bounded context. Now here what is the main activity? Message is the main activity, and now message is what? Who sent the message, status of the message, and content of the message, like what is actually message is all about, like what's in the message. Now there was a very interesting event that we came up with, the notification event, where we were notifying the user. So now the question may arrive, like we have done a user bounded context and the notification and everything is also happening on the user object because user is getting notified, user is getting the updates, like what's happening, what's not happening. So should we put it in user bounded context? So then what we do to decide that, we check the properties of the user object, and we found that in the original user bounded context there were certain properties that are related to user security, right? What were those? Those were these particular properties that was happening practically on user object, which was we were authorizing the user, authenticating it, and giving permission, like what a user can do. User can have different roles: admin, a normal user, right? It can be maintainer, it can be as a proxy also. If it's, let's say it's a chatbot, right? Chat application, so there's a possibility of having an assistant, So these was the property. But in the user notification, we are just notifying the user irrespective of its permissions. Like it's a automated thing. It's not something manually is being done by the user. Of course, message was also the automated part, but it was somewhat dependent on the user activity as well. It was a separate object of whatsoever. And similar to that, we have notification. So we cannot definitely not put just notification into the message bounded context, because nothing is related to notification and message together. It's everything is happening on the message object, and here we have user object. But then when we saw it more deeply, then we realized that actually there was some certain activities that was happening with user object, which was authorization, authentication, and permission, which is unrelated to notification. So here we concluded that this event is not logically related to other two, so we will separate it. So notification will go as a separate bounded context. And what do we need for this? Basically, this notification is happening on basis of user ID, and then specific events will happen on the notification. We will show the status: send, not send, seen. We can notify users that hey, your message has been sent, your message is still not seen, and it has been sent already. Now what we learn from is, like, just because there is user in this object as well doesn't mean that we should get it more, because logic and the request, that the work it is actually doing is totally different. So now the next and final step is, after dividing the bounded context, that is come up with microservice, the final part. Now let's say we name it as notification bounded context. We can also name it as a user notification bounded context. Now when we are coming with microservice, we saw that whatever object they are working for, whatever activity or event they are taking care of, can be converted directly into a microservice. So how will it look like? User bounded context, message bounded context, and we have notification bounded context. So all of these can directly be converted into microservice, and this is quite common practice. And if you are already working somewhere, so you might have already seen it. So this is user management, this is message microservice, this is notification microservice. We can also call it message management microservice, because we are managing all the messages of all the users from this. Right now, there's a possibility, after even coming up with microservices, suddenly someone may think about an event and say, okay, this event is also a possibility. Then what should we do? What we will do, we will check its properties. Does it have some matching properties with our existing context or not? If yes, then we will put it in the appropriate microservice. If not, then we will again find the missing event that is possible required, and we will set it up as a separate microservice. So this is basically a way to come up with a microservice. It's a small process, not it's a big process. It takes time. So there are some important points we can look at in DVD. Minimal amount of duplicacy, no dependency. There should be no dependency among microservices, and a minimal communication overhead. Now what do we mean by minimal amount of duplication? For example, here we did have a little user duplicacy of user ID, because for notification we do need user ID, like from which user this notification has to go, or do we have to notify second user with the first user, mentioning their name, that hey, X send a message to Y, hey, you received message from Y. So this is like, you can make it as advanced as you want to, but you get a gist of it. Like this is the gist of what it actually happens during conversion, and you can also explain all this process to your interviewer, so he will understand, okay, okay, you know about this, so let's move on. When we do come up with a bounded context, for example, this notification service was dependent on user service by a lot, means there were a lot of messages or information that was required from this particular microservice, then we might have to merge it. Or if we don't merge it, if we still decided to keep it to, then called as a distributed monolith, guard ourselves from a distributed monolith. So if we are not following DDD but some other approach, so we have to still make sure that we are not making a distributed monolith instead of a microservice. So this is a good example about it, which is of Amazon. So in Amazon Prime, they used to have two different microservices. One was for audio and one was for video. So they used to have two microservices for audio and video, and there was too much communication overhead between these two, because whenever you are watching a movie, so you need both, right? You don't just need audio, or you just don't need a video. And if it's not a music, like for music, you don't need a video in most cases. So there were too much communication overhead among these microservices in Amazon Prime, that they have to merge it into one single microservice, or you can say a single service. And once they merged it, they literally got 90% efficiency. The reason is pretty simple, right? Because when you have two microservices, then you are basically connecting and talking with different servers. And when you are talking with the different server, there are a lot of things that comes in between: DNS, cache, network latency, security is also a thing, right? So everything comes up in between that adds keep on adding on the latency, and it eats up the server power as well, because server also have to not just process the request but also do a lot of steps that we just discussed about. This was an example of a distributed monolith, and in short we will say they have a tight coupling that causes a tremendous amount of overhead, communication over. So hence Amazon did not move completely microservice. Now with this example we can say that there is no fixed way or magic rule to develop a microservice, but the understanding of domain and business and independency of the services should help us to design an efficient and accurate microservice. So I hope you understand the concepts well, and it will help you in your interviews. If you have any question, feel free to comment down. I will respond as soon as possible. See you in the next one. Thank you.